Hello, Algebra number 3, Quadratic equations and roots. Alpha and beta are the roots of the equation x squared minus px plus q equal to 0. Find the equation whose roots are alpha times alpha plus beta and beta times alpha plus beta. So what's given is alpha and beta are roots of this equation. Now we need to find out how to write a quadratic equation whose roots are alpha and beta. So normally if you write x minus alpha times x minus beta equals 0, then this quadratic equation will have roots alpha and beta, because if I put x equal to alpha, this will become 0, and if I put x equal to beta, this will become 0. Therefore alpha and beta are roots of this quadratic equation. Now we can expand this one to get x squared, x times x squared, x times negative alpha times x negative x alpha, x times negative beta x beta negative, and negative alpha times negative beta equal to positive alpha beta, because negative will become positive. Now we rearrange this one, x squared minus x terms. There are two x terms, x alpha minus x beta, so you take x out, alpha plus beta plus alpha beta. This is our first equation. Now this is given x squared minus px plus q equal to 0 is the quadratic equation. So what we do is we write it underneath this equation, x squared minus px plus q equal to 0, equation 2. Now what we do is we try to compare these two equations and compare the coefficients of x and the constant term. And the coefficient of x here, alpha plus beta negative, and the second equation has coefficients of x as a negative p. So therefore p equal to alpha plus beta, and the constant term q is equal to alpha beta here. So these two are the constants in equation 1 and 2. So therefore we get a third equation here, which is p equal to alpha plus beta and q equal to alpha beta. So now we are going to use the second roots here, second set of roots here, which is alpha times alpha plus beta and beta times alpha plus beta. So what we need to do here is need to write an equation whose roots are alpha times alpha plus beta and beta times alpha plus beta. So we can follow the same rule here, x minus the root times x minus the second root. So first root is alpha times alpha plus beta, second root is beta times alpha plus beta. So very similar to the one that we did earlier. In that case alpha and beta here, but it's a bit complex root here now. Now what we need to do is expand this one. Basically multiply this with x and multiply this with alpha times alpha plus beta. So if I multiply this one, x times x squared, x times x squared, x times negative beta, negative x beta alpha plus beta, negative alpha times alpha plus beta times positive x, negative x alpha times alpha plus beta, and negative alpha times alpha plus beta times negative beta times alpha plus beta. Negative will become positive, alpha times beta alpha beta, alpha plus beta times alpha plus beta become alpha plus beta to the power 2. Here actually coefficients of x equal to beta times alpha plus beta, and this is again coefficient of x equal to alpha times alpha plus beta. So if you take alpha plus beta out, you get the common term alpha plus beta in here, and this negative term will come out here. And also here you get alpha beta times alpha plus beta to the power 2. This is the constant term, this is the coefficient of x, and it's a quadratic equation, equation number 4. Now we have two equations. First equation we got this one, actually it was equation number 3, and the second one, equation number 4, is this one here, is a quadratic equation with the given roots. Now our task is to find out what are the values of alpha and beta in terms of P and Q. So one, we know P is equal to alpha plus beta. We can easily substitute for alpha plus beta here, and Q is equal to alpha beta. So you can substitute there. So therefore, if you substitute P equal to alpha plus beta and value of Q equal to alpha times beta obtained in 3 in the above equation 4 here, hence we can see that the final expression x squared minus x times alpha plus beta times alpha plus beta is equal to P alpha plus beta equal to P, therefore P squared times x plus alpha beta equal to Q from here, and alpha plus beta equal to P. Q P squared equals 0, whose roots are alpha times alpha plus beta and beta times alpha plus beta. So that's the final answer to this question.